morning, Dr. Noor Hafiza and everyone. Today, our group is excited to present our project titled Sustainable Drying Technique, Advancing Energy Efficiency in Food and Non-Food Product Processing. To kick things off, let's talk about green technology. At its core, green technology represents the strategic development and deployment of eco-friendly product equipment and processing system engineer to conserve natural ecosystem, thereby drastically minimizing the ecological damage caused by human industrial activity. In modern manufacturing, adopting this green paradigm serves as a critical milestone required to achieve global climate resilience, lower high factory greenhouse gas emission, and ensure resource efficiency. Across commercial processing industry, this technological innovation are applied to heavily optimized energy-intensive thermal system, eliminate process waste, and systematically replace traditional fossil fuel with sustainable renewable alternative. This brings us to traditional industrial drying process, which have historically relied on direct open air sun dehydration or standard fossil fuel power mechanical convective system. While open air sun drying requires minimal upfront financial capital, it is highly weather dependent, unhygienic, and prone to causing post-harvest raw material contamination. Conversely, automated mechanical convective drying offer industrial operator precise atmospheric control but operate at critical low thermal efficiency, often venting more than half of its primary heat directly into the environment. Because thermal dehydration represents one of the most energy intensive, costly, and carbon heavy hotspot in the supply chain, transitioning to engineer sustainable drying technique has become paramount for global industry environmental compliance. Therefore, the core objective of our paper is to comprehensively evaluate advanced sustainable drying technique and analyze their capacity to elevate energy efficiency across both food and non-food sector.
Thank you, Amir. To drastically curtail the carbon footprint of industrial thermal processing, current engineering focuses heavily on technologies that improve the specific user extraction rather than optimize thermodynamic loops. A prominent advance among this is the heat pump drying or PHD system. Unlike conventional direct fire converse dryer that expel high temperature, human exhaust air straight into the environment, HPD converse process operate via a closed loop rebishment cycle. By channeling the exhaust stream from an evaporator, the system called the Abilo dew point to condense measure out, simultaneously reclaiming the latent heat of evaporations. This recovered energy is subsequently back through a condenser to reheat the dry air before it returns the drying chamber. Recent data related the closed loop the heat pump installation can lower net energy utilization by 60% to 75% compared to typical natural gas or liquefied petroleum gas system. Beyond heat recycling loops, modern operations are integrating hybrid renewable system and with existing processing kinetics. Solar-assisted dryer alters advanced photothermal air collected to generate primary heat, which is supplemented during natural house or overcast periods by biomass gasifier or phase change thermal energy storage units. Concurrently, volumetric heater via electrode technologies has emerged as a disruptive alternative to surface-limited thermal conditions. With assisted solutions like vacuum microwave drying bypass the high thermal resistance of raw material outer boundaries by using electromagnetic wave to directly excited internal water, molecule shifting drying times from hours down to minutes. Furthermore, electron-assisted systems create a structural sponge effects, wherein alternating micro compressions basically pumps measure out through micropressure channels. The mechanical measure extraction bypass the need for phase transformation heat, basically decreasing total electricity usage.
In the food process sector, sustainable drying technology is especially important for providing the quality. For highly perishable products such as food, vegetable, drying product, and seafood, their technology is not remove master but also help maintain important natural components such as vitamin, antioxidants, and neutral pigment. For example, combining ultrasound assisted flow treatment with low temperature vacuum drying can reduce browning reaction and preserve product quality without the need for chemical. The result is serve product better texture and improve hydration properties. In the non-food sector, sustainable drying is wide used industries such as tumbler process, textile, paper production, and pharmaceutical. A good example is tumbler seasoning. Traditional high temperature drying offers cast, crack, and wrapping in wood. However, heat pump drying system provide better master control, allow uniform drying will maintain the structure integrate for the material. Modern initial system can reduce heat loss by up to 30%, make industry preparation more energy efficient. The application demonstrate that the sustainable drying technology are not limited to food product but can improve efficiently and product quality across multi-triple industry. Moving on the sustainability and economy impact. Sustainable drying technology significantly reduce energy consumption and greenhouse gas emission. According to the report, upgrading for conventional drying system to advanced technology can increase thermal efficiency from below 20% to between 45% and 70%. These are in energy use direct low carbon emission and support global sustainability goal. From economic perspective, attract initial investment for equipment such as a heat pump, solar collection, reducing energy consumption linked to long-term saving protection business from fluctuation in a fossil fuel price. Modern sustainable drying system set by technology such as Internet of Things, artificial intelligence muscle sensor, and terminal image camera. This smart system continues monitor and adjust drying condition in real time, providing over drying reduce energy waste and ensuring consistent product quality. Sustainable drying technology provide practical benefit of the both and food and non-food industry by improve product quality, increase energy efficient, reducing environment impact, and support the long-term economy. Thank you.
Next, did you know that conventional industry drying methods are massive energy drain? The thermal efficiency after sit below 20% back to the advanced drying technology are completely rewriting the rule. But under the standard processing plan with modding, general drying configuration thermal efficiency skyrocket to an appreciable 45% to 70%. This structural drop in primary energy consumption directly reduces greenhouse gas emission, aligning factory with strict international net zero mandate. Financially, the initial capital investment for high-end heat pump or solar collector is higher than basic convention setup. However, the subsequent drop in day-to-day power demand create a highly favorable long-term return to investment, inserting enterprise against volatile fossil fuel market. On a systematic level, this sustainable shift is heavily supplemented by digital framework like the Internet of Things, artificial intelligence, and automated sensor. Inline master meter and infrared thermal camera feed data directly into circulated AI algorithm. This smart architecture creates a real-time adaptive feedback loop by constantly modulating thermal output based on the instant drying kinetic on the material. It eliminates overdrying, the primary cause of industrial energy waste, and product degradation combined with digital twin modeling operation become highly optimized and reliable. The future of manufacturing is here. It's time to bright economic target with ecological responsibilities. Upgrade to advanced drying setup and secure your competitive edge today.
Me to wrap everything up for our team, sustainable drying technique marked as indispensable step forward in advancing energy efficiency across both food and non-food processing sector. As we have highlighted throughout this presentation, conventional drying mechanisms are simply no longer viable under modern climate regulations due to their extreme energy demand, low thermal efficiency, and high environmental impact. Transitioning to green innovations such as heat pump system, solar biomass hybrid, and wave-assisted technology enable industry to elevate thermal efficiency up to 70% while drastically slashing carbon footprints. Furthermore, the inclusion of smart digital framework like IoT and AI ensure optimized automated control that limits heat loss and protect product quality. While barriers regarding high initial installation costs and industrial scale-up persist, they can be systematically resolved through targeted economic policy, technical training, and advanced computational modeling. Ultimately, embracing these sustainable technologies is essential to building a low-energy, eco-friendly, and climate-resilient processing infrastructure for the future. Thank you very much for your time and attention.